Hi, this is another video. Showing you guys how to solve the Project Euler problem. So in this session, we're going to solve problem 2. So that would be even Fibonacci numbers. And so I'm going to read the problem statement. The problem statement says that each new term in the Fibonacci sequence is generated by adding the previous two terms. By starting with 1 and 2, the first 10 terms will be 1, 2, 3, 5, 8, 13, 21, 34, 55, and 89. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million. So by considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even value terms. So this is the solution. And so here is the code that I have written. So the code goes like this. So we're gonna create a loop that calculates the Fibonacci numbers. So Fibonacci numbers is by adding the previous two terms. So for example, 3 is generated by adding 2 and 1. 5 is generated by adding 3 and 2. 8 is generated by adding 5 and 3. 13 is generated by adding 8 and 5. 21 is generated by adding 13 and 8, and so on. So we're going to start with Fibonacci number, the first one, and the second one is going to be 1 and 2. The nth one is going to be 2. And then we're going to calculate, so all the even numbers should be added. Find the sum of the even value terms, and then we're going to calculate the result. The way we're going to do that is we're going to check if the current Fibonacci number that we've generated is divided by 2. This is modulo 2 like we did in the previous section, in the previous problem. If it's divisible by 2, then we add it to sum, because if it's divisible by 2, that means it's even. And this modulo 2 is what tells us it's divisible by 2. So Fibonacci number n, this is how you calculate the Fibonacci number. So this is just a clever way of writing. Yeah, so I kind of did it. I could say int temp equals fib n equals fib1 plus fib n, and then I could say fib1 equals temp. So I don't necessarily need to write that. So what this does is it temporarily saves the current Fibonacci number, then it increments the previous Fibonacci number to this. So fib1 stores the previous Fibonacci number, fibn is the current Fibonacci number. So we're just going to add, so it's like the current Fibonacci number is 2. If the current Fibonacci number is 2, then the previous one is 1. And then to calculate 3, we just add 2 to 1. So the previous one to this one. So this is a common way of implementing Fibonacci numbers. You can go Google it. This is very, very common. And then once we're done, we display the sum. So we do this until the Fibonacci number is less than 4 million. The moment it exceeds 4 million, then we stop. So if we run this, yeah, so it gives us 4,613,732. And that would be this. And the answer is correct. And that's it.